The objective of this video is to practice balancing chemical equations. Let's look at the first equation. You have S8 and fluorine, which result in SF6. If you are good at balancing it mentally, you can go ahead and balance it out. If not, you can start sorting out the type of element and the number of atoms in both sides and try to balance them out one by one. So I'm going to list the number of elements and atoms in each side. I have 8 sulfur atoms on reactant and 1 sulfur atom on product. I have 2 fluorine atoms on reactant and I have 6 fluorine atoms on product side. Now since I have these 8 sulfur atoms on reactant side, I'm going to add the coefficient. Keep in mind, we add only coefficient, we never touch these subscript. Now I have 8 sulfur atoms, but at the same time it changes the number of fluorine atoms I have on product side. 8 multiplied by 6, that will give 48 fluorine atoms on the product side. That means I should have 48 fluorine atoms on this side. If I want to have 48 fluorine atoms, then I need to add the suitable coefficient, which is 24. 24 multiplied by 2, you get 48. Now all the different types of elements and their numbers are matched. This equation is balanced now. Let's take another equation. It's always easier to start with the most complex molecule and end the balancing process with the elemental species. Now here I'm going to list out, I have 4 carbons on reactants, 1 carbon on product. I have 10 hydrogens on reactant and 2 hydrogen on product. I have 2 oxygens on reactants and I have 2 plus 1, 3 oxygen on products. Now I'm going to add the coefficient 4 to balance out the number of carbons. So now I have 4 carbons and I have 10 hydrogens here on reactant side, so I'm going to add a coefficient to make the number of hydrogens as 10. So the coefficient I should be using is 5. 5 multiplied by 2, I get 10 hydrogen atoms. Now making these changes with coefficient changes the number of oxygen atoms. 5 multiplied by 1, that is 5 oxygen atoms coming from water, and 4 multiplied by 2, that is 8 oxygen atoms coming from carbon dioxide. 5 plus 8, that is going to result in 13 oxygen atoms. If you have 13 oxygen atoms on the product side, you should get 13 of oxygen atoms on the reactant side. Now this is an odd number. So divide this number by 2. What do you get? You get 6.5. You can leave it either as 6.5 or as 13 divided by 2. Both of these forms are correct to leave. But now it is the time to think about the definition of a balanced equation. You should have the simplest whole number ratio. Now this is not a whole number, this is a fractional number. So what you can do is multiply the whole equation by a suitable coefficient to bring everything to the smallest whole number ratio. You can start by multiplying by 2. So multiply this coefficient. You don't see anything, that means you have 1. So multiply 1 by 2, you get 2 C4H10 molecules. Multiply 2 by 6.5, that is 13 water molecules, resulting in 5 multiplied by 2, 10 H2O plus. Multiply 4 by 2, that is 8 carbon dioxide. Now this is your balanced equation, which shows you the simplest, the smallest whole number ratio. Another equation. It's always easier to start with the complex molecules and end with the elemental forms. Alright, let's list out the element types and the number of atoms. I have one copper atom on this side and one copper on that side. Chlorine, I have two chlorines on reactant, and how many chlorines on product? You have three chlorines. Now considering aluminum and copper, they are balanced. However, chlorine is the only one that look like it is not balanced, and the numbers you have is 2 and 3. Think about the common number, the smallest common number that you can divide by both 2 and 3. That would be 6. That means if you have 6 chlorine atoms, you can balance this out. So I'm going to have 6 chlorine atoms here. So if you want to have 6 chlorine atoms, think about the coefficient you want. You need coefficient 2. 2 multiplied by 3, you get 6. Now you need the same number of chlorine atoms on the product side, the reactant side. So if you add the coefficient 3, 3 multiplied by 2, you get 6. Now your chlorines are balanced, but it is going to change the number of other atoms. Now this coefficient 2 is going to change the number of aluminum atoms. Now you have 2 aluminum atoms in products, so that means you must have 2 on the reactant side. This coefficient changed the number of copper atoms into 3. That means you must have 3 copper atoms on the product side as well. Now check the numbers. Are they balanced on both sides? Yes. Now this equation is balanced. Another equation. Now you must be very good with the polyatomic ions that you should be able to identify them when you see an equation. Keep in mind, when you balance equations that hold polyatomic ions, we do not balance each and every atom one by one. Instead, we consider this whole polyatomic ion as one group. Now I'm going to list out things in both sides. I have 3 sodium atoms on reactant side and 1 sodium on product side. I have a phosphate group. I have just one phosphate group, and it is because of this one we just don't show the brackets or the number. I have only one of them, and on the product side, how many do I have? Outside the bracket, you see the subscript signifying you have 2 phosphate groups. Calciums. How many calcium you have? You have 1 atom on reactant. On the product side, you have 3 calcium atoms. And then I'm going for chlorine. I have 2 on reactant side, and on the product side, I have only 1. Now I'm kind of going to focus on more complex molecules. I'm going to look into these number of phosphate groups I can find in both sides. I have 2 on this side and only 1 on the reactant side. So what I'm going to do is I'm going to add a coefficient 2. When I add this coefficient 2, the number of phosphates increase to 2. What else happens is the number of sodium. Now 2 into 3, I'm going to end up with 6 sodiums. If I end up with 6 sodiums on the reactant side, I must have 6 on product side. That means I'm going to add this coefficient. Now I added 6 sodium. This coefficient is going to change the number of chlorine atoms I have on the product side. Now this means I have 6 into 1, 6 chlorine atom on the product side, meaning I should have 6 chlorine on the reactant side as well. If I want to get 6 chlorine, I need to add the suitable coefficient. The suitable coefficient is going to be 3. Troubleshoot. 3 multiplied by 2, you get 6. Now what happened to the number of calcium ions? I have 3 calcium ions. check if numbers and all elements balance. 6, 6. Phosphate I have 2 on both sides, calcium 3 on both sides, and chlorine I have 6 on both sides. Now this equation is balanced. Let's look into another equation. Again, you should be able to realize that this is nitrate, which is a polyatomic anion. Sort things out. You have copper, 1 copper, just 1 atom in both sides. You have chlorine, 2 on reactant side and 1 on the product side. You have silver, 1 atom on the reactant side and silver, 1 atom on the product side. Then nitrate, you don't consider nitrogen and oxygen separately. You consider this whole thing as one group. You have 1 nitrate group on reactant side. How about on the product side? You have 2 of them. Now it's easier to start with the most complex ones. Since you have 2 nitrates on this side, try to balance out the nitrates first by adding the coefficient. Now 2 multiplied by 1, you end up with 2 nitrates. Look like the nitrates are balanced. But this addition of coefficient changes the number of silver atoms. Now you end up with 2 silver atoms, which means you must have 2 silver atoms on this side as well. That means you need to add this coefficient 2. Adding the coefficient 2 to silver chloride changes the number of chlorine atoms. You know, when you don't see a subscript, by default you have number 1, 2 multiplied by 1, that is 2 chlorine. Now you have balanced out the number of chlorine atoms. How about the copper atoms? Now check all the numbers. Copper, you have 1 atom, 1 atom. Chlorine, 2, 2 in both sides. Silver, 2, 2. And nitrate ions, 2 in both sides. Now this equation is balanced. Right. Another example. Sulfate. You should be able to identify sulfate as a polyatomic ion. Sort out things. You have 1 zinc, 1 zinc. Copper, you have only 1 copper, 1 copper. And you have sulfate, you have only 1 group on this end and only 1 group on the other end. So what do you think? This equation looks like it's already balanced. You have all the different types of elements in equal number in both sides. Alright, another example. Now pause the video for a minute and try to balance this out by your own. Alright, I'm going to sort out the number of atoms in each side of the equation. I have 8 carbon atoms on reactant and just 1 carbon atom on product. Hydrogen, 18. Hydrogen, I have only 2. Oxygen, I have 2. And on this side, how many oxygen? 2 plus 1. That is 3 oxygens. So I'm starting with the most complex one. I have 8 carbons, so I'm going to add the coefficient 8. And then I have 18 hydrogens. So if I add the coefficient 9, 9 into 2, that is going to change the number of hydrogen atoms into 18. Now I'm going to look into how many oxygen atoms I'm going to end up with. 8 into 2, that is 16 oxygen atoms from carbon dioxide plus 9 into 1, that is 9 oxygen atoms from water. So how many oxygen atoms should I have on the product side? That is 16 plus 9. That is 25 oxygen atoms on the product side. If I have 25 oxygen atoms on the product side, I must have 25 oxygen atoms on the reactant side. So if I need to have 25 oxygen atoms, the coefficient I should put over here is either 25 divided by 2. You can either put it like this, or you can put it like 12.5. Either you can put 12.5 or 25 divided by 2. Now, this is not a whole number ratio, so multiply it by a suitable number to get the smallest whole number ratio. So that means you're going to end up with 2 C8 H18 plus you're going to have 25 oxygen molecules, 16 carbon dioxide, 9 into 2, that should be 18 H2O molecules. Now this is your balanced equation. Why? It is the one that shows the smallest whole number